All right, so the practice is giving us this scenario over here where we have these three different equations going on. So we're bounded between y equals x squared plus 3, y equals 3, and x equals 2. And then we're trying to find the volume when we rotate around a whole bunch of different shapes. And some of them are straightforward and some of them are not. So let's start off with A if we're going around the x-axis. So if we're going around the x-axis, okay, then our radiuses are going up from here. So I'm going to have a big R of x squared plus 3 and a little r of 3. Okay, so I'm just going to write that down, x squared plus 3 and a little r of 3. So when we set up the equations, we're just going to have pi, the integral from 0 to 2, because those are the x values, of big R, so x squared plus 3 squared, minus little r squared. And if we plug that into the calculator, we're going to get 112 pi over 5 units cubed. So that one wasn't that bad. B, which is the one that went sideways here, this is around the y-axis. So this time if we rotate around the y-axis, okay, our big R is actually going to be x equals 2, okay, because I'm going from this way, and our little r is going to be the red equation, or the square root of y minus 3. So then I just have to plug this into the formula. So I got pi, I'm going from, this is from 3 up until 7 is where that intersection point is. So 3 to 7 of 2 squared minus the square root of y minus 3 squared dy. I used my calculator for this. I got 8 pi units cubed. C, we start getting slightly more challenging, but it's not actually that bad. We have y equals 3. So we're rotating around this line right here, which means that we're going up and down, so it's going to use the x's in the equations, and we're rotating about this, which means that we only have a single radius, which is the x squared plus 3, but we need to subtract the fact that we're not going all the way down here. So I'm just going to subtract the starting point, which is 3. So in this case, my radius, the only radius I have, is x squared plus 3 minus 3. Okay? That minus 3 there, again, that's because we're starting from up here instead of here. So we need to remove this extra 3 bits of space here. So when I plug this in, I will just get pi, and then the integral of x squared plus 3 minus 3. No, you don't need to write it that way. I'm just being formal. And when I plug that into the calculator, I got 32 pi over 5 units cubed. Part D, which goes sideways from C, this is going to be rotating around the line x equals negative 2. So this is starting to get a little bit more challenging. So I'm actually going to put a little dotted line where this is. So I'm rotating around this line right here. So that means that I have to include this extra 2 right here in order to get to this line, and then I have to get up to that. So our big R and little r are a little bit trickier to figure out. So my little r is what I've actually drawn so far. It's going to be 2 plus the square root of y minus 3. My big R is going to go 2 to get me to here, and then I need to go an extra 2 to get me over to the green line that we're then ending on. So big R is actually just 2 plus 2, and then I just plug it into the equation. So I think from this point forward, all I'm going to do is just write what big R and little r are, that's hard to say, for the last 4, rather than me actually writing the whole thing out. So we're just going to talk it through. Where do we get big R from? Where do we get little r from? And go from there. Every time that we integrate with respect to x, we are doing this from 0 to 2. Anytime that we integrate with y, we're going from 3 to 7. For E, we're rotating around the line y equals 8, which is way up here, okay? So what we need to do is always focus on where we are from that point that we're rotating by. So here's y equals 8, and then we have these guys that are down here that are kind of intersecting, right? So when I go to figure out my radiuses, it's a little bit trickier to do. I basically start at 8 and then I need to subtract to get me to the other values. So for E, my big R is actually going to be 8 minus 3, so 3 right there, 8 minus 3. So I start at 8, and then I'm subtracting the equation that I hit. Little r then is just 8 minus this equation here, which is x squared plus 3. I need to use parentheses around that because I'm subtracting. Okay, so when I'm rotating around a line that is above it like this, I'm going to be subtracting the equations from it. Same idea for f. This time I have a line way over here at x equals 10, and I still have those same regions that are over here, but this time I'm rotating all the way from here. So I'm going to again end up subtracting values in order to get these. And since I'm rotating around a vertical line like this, I'm going to be using the y's in my equations. So in this case, the further away from 10 that I go, that brings me to the curved equation. So my big R is going to be 10 minus the square root of y minus 3, the curved equation. Little r is going to be 10 minus this value right here, which is going to be 2. And I'm pretty sure I wrote that wrong in my answer key because I have written down 3, but I'm like 95% sure that it's definitely supposed to be 2. So I'm not sure why I wrote 3 there. It's definitely 2. That means that the number in my answer key is probably wrong because I definitely plugged it in with a 3. So not sure what's going on with that one. G, we have the line x equals 2. Okay, so that's right here. So when I'm looking at this, my radius needs to take that into account, but I'm only going to have a single one, which is this guy right here. So I'm going to have just one radius, which is going to be 2 minus the square root of y minus 3. That's going to help me figure out what that little rotation is. Okay, so only a single radius there, not a second one. Last but not least, we have h, which is the line y equals -3. Okay, so that's way down here. So when I'm rotating there, I need to actually add a 3 value, okay? Because I'm going all the way up. So I'm going from here, which is positive values, and an additional 3 places past that. So for this one, my big R is going all the way up to the curved equation. So that's going to be the x squared plus 3, and then I need to do my extra plus 3. My little r is going to go up to this 3 right here, and I need to include that 3, so I have plus 3. So to kind of summarize this, when you're rotating off of the axis, basically if you are below the axis that you're normally used to rotating, so here we are below the x-axis, we actually add the distance. If we were above it, we would subtract the distance. Same thing if we're going with the y equations. If we're below it, we're going to be adding. If we're above it, we're going to be subtracting.